Okay, now we're going to talk about heating something and how much heat is required to get it to go through a phase change. Because remember, when we're heating something, we are not changing the temperature. See, here's what I would suggest you do, okay? Think about a heating curve and draw a heating curve for every single one of these. Okay, so you know and read through the problem, where is this going to happen? If you know there is a phase change, you know, remember, you were on one of these plateaus. And if we're talking about water, this plateau occurs at 0 degrees Celsius, because remember from the gizmo, water boils or water freezes and melts at 0 degrees Celsius. At the second plateau, that is my boiling or condensation, that is my 100 degrees Celsius. So we know, if we're talking about water, where those plateaus actually occur. Okay? So if we look at the problem, you might want to turn to page 7. Again, I provided you a little bit of space for notes and the 2 example problems that I'm going to show you. Okay? So looking at the first one, it's telling us to calculate the energy required to melt 250 grams of water. So again, I'm looking for Q. I'm looking for energy. Okay? However, if we try to use the last one, the last equation that I gave you, Q equals MC delta T, I have Q, or I'm trying to figure out Q. I have M. I know it's water, so I could use specific heat, but I have no change in temperature. That's because I'm talking about melting. Where on my phase change am I at? I'm right here. I'm at this plateau. Okay? So if I try to plug a change in temperature of 0 into there, I'm going to get Q as 0. We all know, we've talked about, that even though I am adding energy at that phase change. Okay? So I have to have Q being added. So how do we get there? There's actually another equation. Q is equal to H times M. Q is energy again. M is mass again. And of course in grams, this H value. This H value is just like my specific heat, although it's what we refer to as either heat of fusion or heat of vaporization. Why do we have 2 different values? Because I have 2 different plateaus. Okay, so my values down here, my heat of vaporization is 2,260 joules per gram, and my heat of fusion is 334 joules per gram. So where do each of these lie? My heat of fusion is my first plateau. It's my melting or freezing. So this is where I would use my fusion value. My second plateau is my vaporization. Okay, so in the first problem that I asked you, I'm melting. So I know I am on this first plateau. This is why it's so critical that you know when I say melting, where on this curve you're at. So I am right here, which means I'm going to use Q equals H times M because I have no change in temperature. So Q, and I'm at my fusion, so I'm going to use my fusion value, 334, and my mass, trying to melt 250 grams of water. And I just plug it in. So 250 times 334. And that's my 83,500 joules. Again, it's going to seem like a big number. Okay, because you do need to add an awful lot of heat in order to melt that much ice. Let's look at my next one. Determine energy released when 1,000 grams of steam is condensed. Okay, so I'm talking about condensing. There's no temperature change, so that should clue you in that you are going through a phase change. I'm now at my second plateau. So I'm going to use Q is equal to my 2,260 times my mass. So my Q is equal to a very, 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 very large number. And there you go. Now, there's something else that I want to mention. Okay? This key word over here, energy being released. Since it's released, that would be an exothermic reaction. Now, that does slightly change our Q value. Whenever energy is released or whenever something is exothermic, we need to throw a negative on there. Okay, so it's really negative that much amount of energy. When you see that negative, that is cluing you in that you need to remove that much energy. So whenever you see a negative, that means that it's exothermic. Whenever you see a positive Q value, that means that it's endothermic. That's the amount of energy to put into that particular substance. Okay? That's actually why the first time, if you look at the problem, it says required to melt. Well, in order to melt something, you need to put that energy into it. Okay? So whenever you do not have a change in temperature, you have a phase change. When you have a phase change, you now are not going to use Q equals MC delta T, because if I use Q equals MC delta T, my Q will always come out to 0, because 0, change in temperature, times anything is 0. But we know there is energy being added to it. So you need to use that second equation that I'm giving you, Q equals H times M.